Hello everyone and welcome. In this video, I'm going to talk about variables and data types in C++, so let's get into it. So in C++, there are various ways that you can store data. You can store data as integers, floats, Boolean values, strings, or characters. So all of these are going to be data types in the C++ language. So let's start with integer, which is going to be represented by int. So an integer is any whole number. So any number that doesn't have a decimal point is going to be an integer. So stuff like 31, 0, minus 100, 20, all of these are going to be integers because they are whole numbers. They don't have a floating point. Now, if they do have a floating point, they are going to be called float. So a float is stuff like 2.9 minus 6.0, 0.174, all of these are going to be float data types. Now, notice that minus 6.0 is going to be a float data type. It's not going to be an integer data type because although this represents the number minus 6, right, because minus 6.0 is minus 6, this is not going to be an integer since it has a decimal point. This is going to be a float. So next up, we have Boolean values. Boolean values are going to be either true or false. There are no other Boolean values. There's only true or false. Now, notice that both of these keywords are written with lowercase letters. So if I write false like this with uppercase in the beginning, this is not going to be a Boolean data type. This isn't going to be any data type because the program doesn't know what this is. So be careful with that. Boolean data types are words that have lowercase. Now, what happens when you try to print a Boolean data type to the console? So if I see out true like this, and let me just comment these out. Let me run this. So if I run this, you can see that it's going to output 1. And if instead of true, I output false, if I run this, this is going to output 0 as you can see. Now, why does this happen? So in some languages, C++ being one of them, 0 represents false and any number but 0 represents 1. So when you output false to the console, it's going to output 0, which is equivalent to false in C++. And when you output true, it's going to output 1. It can actually output any number because any number but 0 represents true in C++, but it outputs 1 by default. So when you output true, it's going to output 1, which is equivalent to true in C++. So that's why this happens. Let's move on to the next data type, which is going to be a string. So the string isn't built into C++. What does this mean? If you want to use a string, you have to include it in your program. Otherwise, the program isn't going to know what string is. So it isn't going to know that it is a data type that is used in C++. So in order to use a string, you have to include it. You have to say hashtag include the string, like so. And now you can use a string safely, and the program is going to know what to do with it because it knows that it is inside of that string library. So a string is going to be anything that's in between double quotation marks. So normally you'd use a string to represent words or sentences and stuff like that. So stuff like hello world, this is going to be a string. Notice that true in between quotation marks, it's also going to be a string because although true is a Boolean data type, it is in between double quotation marks, and so it's going to be a string. And the same for numbers, because if a number is in between double quotation marks, so 30 in between quotation marks, this is going to be a string as well. So the last data type that I want to show you, it's going to be a char or character. And a char is anything in between single quotation marks. So a string is anything in between double quotation marks. A char is anything in between single quotation marks. With one condition, in between quotation marks, in between single quotation marks, if you want it to be a char, you can only put one character at a time. So stuff like Q in between single quotation marks, this is going to be a char. 1 in between single quotation marks is going to be a char, exclamation point. One more example, a plus sign. This is going to be a char data type. Now, something like hello in between single quotation marks, this isn't going to be a char, although it is in between single quotation marks. Because in between quotation marks, you can only put one character at a time in order for it to be a char. So this isn't going to be any data type in C++. This isn't going to be valid. So what happens when I try to output this? So let's say cout hello with single quotation marks like so. Let me just comment these out. So let's run this code. Let's see what happens. So as you can see, this is going to give me a warning. It says character constant too long for its type. This is because we put multiple characters inside of single quotation marks and we cannot do that. And then it's going to give me this weird number right here. So why does this do this? So this actually happens a lot in C++. So when you try to output something that isn't defined or doesn't exist, or something that just isn't valid output, which is the case right here, what's going to happen is the program is going to output the memory location of that thing. So that's why this happens. So let me delete this. And now let's talk about variables. So a variable is something that can store a value so that you can reuse it throughout your program. Okay? So how do you define a variable? First of all, you're going to tell the program the data type that is going to be contained in that variable. So I want to create a variable called x, which is going to store the number 10. So 10 is an integer, so I'm going to tell the computer that this variable is going to hold an integer. I'm going to say int, and then the name of the variable is going to be x, and I want this to equal 10. So I want this variable to store the number 10 inside of it. So now if I try to output x, so if I say cout x, and I run this, this is going to output the value of the variable x, which is going to be 10. So if you want to create a variable, you're going to say first the data type of that variable, then the name of the variable, and then the value of that variable. And when you try to output that variable, it's going to output the value that it's stored inside of it. So if I want to create a string variable, I'm going to say string, which is the data type of my variable. The name is going to be name, and it's going to be equal to Mike. So now if I run this, you can see that this is, oops, let me just output this, which I forgot to do. So let's output name and run this, and this is going to output 10 and then Mike. So that's how you define a variable in C++. That's what a variable is. So some cool stuff that you need to know about variables. So let's redefine that variable x that I had before, but now let's add it a decimal point. So what happens when I try to cout x? So if I try to cout x, this is going to output 10 and not 10.9. Why does this happen? So up here, I defined x to be an integer data type, right? And then I went ahead and I stored a floating number, a decimal number inside of x. And so when I try to cout x, the program is going to say, okay, x is an integer, let's output an integer. But actually what's stored inside of x is 10.9, which is a float data type. So what happens when you try to output x? The computer is going to output the integer that is associated with x. So it's going to cut off the floating point. It's going to cut off the decimal point, which in this case is 0.9. And it's just going to output the whole number, which is going to be 10. So rounded down always. Now, what happens when you say that this is a string? So instead of int, let's say string, and let's keep x as being 10.9. So if I run this, this is going to give me an error. It's going to say conversion from double to non-scalar type requested. So basically what this means is that you can't really turn a string into an integer. Those data types aren't compatible like the float and integer are, right? So you can't really convert a string into an integer, and you can't convert an integer into a string. That's what this is telling us. Now, what happens if I say true? Oh, not true. I didn't mean true. I meant bool. So what happens if I say that X is a bool data type? So if I run this, you can see that this is going to output 1. What is happening here? So I told the program that X is going to be a Boolean data type. Boolean data type is going to be true or false. False is represented by 0, true is represented by any number that isn't 0. In this case, X is equal to 10.9. 10.9 is different from 0, and so it's going to be true, right? But when you output true to the console, the program isn't going to say true in the console. It's going to say 1, which is the defined value for true. And so when you output X, it's going to output 1, which is equivalent to true. So hopefully that was clear. Let's move on to some rules that you have to consider when you're creating variables. So the first thing you have to keep in mind is that the names of your variables should be short but descriptive so that you or any other person that looks at your code knows instantly what type of value some variable is holding just by its name. So let's change this back into an integer, and instead of X, I'm going to call this number. And notice that this is really short and it's really easy to write, but when you look at the word number, you already know what that variable is going to hold. So it's going to be much easier to understand. Now, if you want to name a variable multiple words, so if you want to say, for example, number 1, instead of writing number 1 like this all together, you're going to separate the words by an underscore so that it is more readable. Let me actually delete this because we don't need it anymore. Now, in C++, you don't really do this. You don't really use an underscore to separate the words. You use camel case. It is better practice. So if you say number 1 with a capital O, this is going to be just as readable, and it's going to be more C++ like. So always keep this in mind when you're naming variables. Now, the second thing that I want to show you is that you don't really have to initialize a variable. So once you create a variable, you don't really have to assign a value to it immediately. So if I just say int number 1, this is going to create the variable number 1, and it's going to be of type integer, but it is not going to have a value yet. Okay? Now, in the previous video, I told you that you can get input from the user into your console. So if you want to do that, first of all, you have to create a variable, which is what I've done here. And notice that this variable isn't initialized, it doesn't have a value. And now I want to input some value, and I want to store it in this variable number 1. So how can I do this? I'm going to cin characters, I'm going to input characters, and then the operator, these arrows right here, are going to be facing inwards, right? Because I'm inputting something. And then I want to input a value which is going to be stored in the variable number 1. So I'm going to say cin number 1, okay? And now if I run this and I say 10, for example, this is going to store 10 in number 1. So now if I cout number 1 like this, number 1, and I run this, let me just redefine number 1. This is going to print automatically 10 onto the console. So that's how you can get input from the user. So let me give you another example. I want a string with the name of the user. So I'm going to cin the name, okay? And then I want to output, so I want to output cout hello, hello, and then the name. So I'm going to put the arrows again, and I'm going to say name. So now if I run this, let me say, oops, error, no type, name type. What did I do wrong here? So string name, cin name, oops, I actually put this backwards. So this should be right now. Let me run this. Okay, so it's working correctly. Let me input Mike. So Mike is going to be stored in the variable name because I wrote cin name. And then I want to cout hello and the name that I've just inputted. So I inputted Mike, and then the program automatically outputted hello, Mike. So I hope that was clear. If you don't understand something, don't hesitate to ask. So the next thing that I want to talk about is that you can't really name two variables the same. So if I say string name and then I say int name equals 2, then this isn't going to work. So if I say cout name like so, and I run this, as you can see, this is going to give me an error. It's going to say conflicting declaration in name, previous declaration as string name. So I can't really name two variables the same name, okay? I always have to choose unique names for my variables. Now, that doesn't mean that I can't update my variables. So if I say int name equals 2, then I've created the variable name. Let me actually change this to num because name isn't very descriptive. So I've created the variable num, which is going to be an integer, and I've stored 2 inside of it. But now if I say num equals 0 and I run this, then you can see that this is going to output 0, right? Because first the value of num was 2 when I defined the variable, and then I've updated the value of num to 0. And so when I output num, it's going to output 0. Now, other ways to update variables are, for example, plus equals. So if I write num plus equals 1, then what this is going to do, it's going to add 1 to the variable num. So first num is going to equal 2, and then I've added 1 to it, and so now it's going to equal 3. And so if I run this, this is going to output 3. And if I say num plus equals 8, and I run this, then you can see that this is going to output 10. So num is going to start out as 2, and then I'm going to plus equal 8, and then the cout statement is going to output 10, which is 8 plus 2. Notice that here we aren't redefining the variable, so we aren't creating another variable with the name num. We're just updating the previous num that we had before. So we're just updating this num variable right here. So this isn't going to cause any problem. So the last thing I want to talk about are constant variables. So if you have a certain value that you want to store in a variable and you know for sure that that value isn't ever going to change, you can create a constant variable. So to do that, you're going to write const to indicate that this is a constant, and then the data type of that variable. Now the data type of my variable is going to be an integer, and the name is going to be num of students. So this is going to store the number of students of a hypothetical class, for example, 20. Okay, so let's go over this one more time. So first of all, I've told the program that this is going to be a constant. So like the name indicates, I'm not going to be able to update this value ever in my program. It's always going to be 20. And then I've indicated the data type, which is an integer, the name of the variable, and then its value. So if I say cout num of students like so, and I run this, this is going to cout 20. So as you can see, this works as a normal variable. The only difference is that I can't update it. So if I do something like num of students plus equals 10, and then I cout num of students like so, and I run this, as you can see, this is going to give me an error. It's going to say assignment of read-only variable num of students. What does this mean? It means that I assigned a certain variable, a certain value to a variable that I can't change. So that's how a constant works. So a constant is a normal variable, but you can't really change it. Now, something that you can't do with constants that you can do with variables is you can't not initialize it. So you can't say constant and then the name of the variable and not assign it any value. Okay, if I write cout num of students, num of students like so, and I run this, as you can see, this is going to say initialized const num of students. So you can't do this in C++. So that's all I have to show you in this video. Thank you for watching. If you have anything you want to ask me, please do, and I'll answer you as fast as I can. In the next video, I'm probably going to talk about operators and user input in more detail. But for now, let's just stay at this. Thank you for watching, and I'll see you in the next video.